Hello, everyone. Welcome to our LeanCode webinar about how to automate end-to-end testing in Flutter. I'm Mateusz, and I'm head of mobile at LeanCode. Also, I'm a Google developer expert for Flutter and Dart, and I'm overseeing our Patrol team.
Hi, I'm Oscar. I am a QA automation engineer at LeanCode, and I'm also a member of the Patrol team.
Great. We are from LeanCode, which is software studio straight from Warsaw, Poland. We've been building great products for almost 10 years right now. And we're pretty known in the Flutter space. Maybe you have already heard about us. In Flutter, we've built everything from small startups to large enterprise banking apps. As you can see, we worked with a lot of known brands. And we also do architecture audits, consulting, everything related to Flutter and hard Flutter cases. So the agenda for today is to talk about what is end-to-end testing, how to test Flutter apps, what are the first-party solutions for that, a brief introduction to Patrol, our UI testing framework, how we can leverage other test tooling with Patrol, how Patrol and our UI tests enable us to use other tooling out there, our example setup for one of our clients that we did, and a bit about best practices when using Patrol. So to start with, what's end-to-end testing? End-to-end testing refers to a comprehensive validation method that tests an application's workflow from start to finish. It verifies that each component functions correctly within the entire system in real-world scenarios, ensuring the software behaves as intended from the user's perspective. This is the definition that I took from a browser stack, and it's quite precise because why would we do that? So what are the goals of end-to-end testing? As we already said in the definition, we want to know that everything works together. So it's very useful when we switch environments, when we go from one environment to another. We can test the real user experience because when the user interacts with the app, they actually interact with the whole system. They interact with our app, with the backend, with third-party services, and we can test the whole experience. What's also crucial is that we can test regressions. Many times we use end-to-end tests with regression testing. It means that we want to execute critical business paths that are crucial for the core purpose of the business, so that we know when we launch a new version, when you release to production, for example, we know that we make money, that there are no critical bugs that would destroy our business. And last but not least, there are things that you can't test with other tests. So there are some hardware integrations that are not related to app, but to the device, like a Bluetooth or NFC, or third-party integrations. So payment processing, some another microservice, another backend, third-party Stripe or PayPal, or third-party authentication like signing with Google. So as we already said, it's not only about the app. It's about testing the whole system, the whole product. So if we are testing the whole product, are end-to-end tests sufficient? Well, actually not. They could be, but there's a trick in here that end-to-end tests are slower and more expensive to run because we actually interact through the app like the user would with the whole system. So it takes much more time, much more money, much more, CI/CD minutes and so on to test all the paths. That's why we have this testing iceberg, I would say, where the end-to-end tests are just at the tip. Another thing that's many times people are not sure about is UI testing term and end-to-end testing term. So we use both because UI testing refers to literally testing user interface, right? And when we interact with the app, when we click on a button, when we check if something's of a color or if we want to see if something's visible, we actually test the user interface. But the user interface, as the name is, it's how user interacts with the app. And the app is how user interacts with the system. So if we want to actually end-to-end test how user interacts with the system, we want to do it with testing the UI and through the UI layer. So what we actually want to do, we want to do the UI testing in Flutter so that we end-to-end test the whole system. That includes the Flutter app. So we want to do the UI testing of our app. What are the first-party solutions for that offered already by the Flutter team and Flutter framework? There are two of them. First is integration test, and another one is Flutter driver. Integration test is just a thin wrapper that can run your widget tests on device. Widget tests mean that you can just, run the Flutter engine with your widget, but it can be also the whole app because your whole app is a widget. And integration test can run this on your device. So it's kind of mocking like running the whole app as a widget test, but on the real device. And this is an example of a gray box testing, meaning that you are inside inside the runtime of your app. So you can actually use the code of the app. You can interact with things that are in the app, and the code stays in the same code base. Another solution is Flutter driver, which is a black box solution, meaning that it's instrumenting your app from the outside. The test code can be totally outside your app code. You are in a whole different runtime. You just communicate with the app from your host, from your computer, for example, through some interface. So all the actions that you want to perform, like tapping a button or finding something on your screen, are actually serialized and sent as requests to your app that takes them and converts them to the actual actions. What are problems with first-party solutions? Because first, what we want to do is to use the first-party solutions always. And that's also what we wanted to do when we started the deep dive into the Flutter UI testing as LeanCode. We started with exploring first-party solutions. First problem of first-party solutions, both of them, is native automations. So there's no framework that can test both Flutter and native automation in one scenario, which is Dart, a pure Dart, like when you just write Dart code. So integration test is pure Flutter, Flutter driver is pure Flutter. What are native automations and why is this a problem to you or your app? It's every time you might want to interact with a native dialog, so the system dialog, like iOS dialog, Android dialog. As you can see on the first screen, you might have a dialog about the app wants to use Google.com to sign in. Another thing is you might have a web view, which is also a native Android or iOS view. Another one is a location permission pop-up or notification permission pop-up. And on the fourth one, you can see a third-party native screen like PayPal. And you, for example, integrate some third-party SDK that's native, like PayPal or, I don't know, Stripe or anything, which is crucial in your business path. Like it's critical. You cannot omit it. You have to go through it. And it's native, so you cannot interact it with the Flutter world solutions. This is why it's very important and why it's like a blocker issue. Another problem is the developer experience. Here you can see the code that you would write with integration tests. So on the left side, you have a lot of code that what it actually does is that it enters text 3 times and taps 2 buttons, right? So it's just 5 actions, but the amount of code you have to write and how hard it is to read from it, that it's only these 5 actions, is very considerable. On On the right side is even more hardcore example, I would say, because this is when you would like to find something that's inside other widgets, like a widget inside other widget, or a widget that has another widget. In this case, you have to think in a whole different way that you would think as a human. So you think about tapping something, then you think about ancestors and descendants. It's very verbose, and at the same time, it's very not intuitive. This is the developer experience problem. And last but not least, there's a huge problem with CI/CD and device farms. What it means is when you use integration test out of the box, it's hard to take advantage of all the features that are available on device farms and cloud solutions dedicated to running native and not native mobile UI tests. And it's very important because, as you will see later in this webinar, we would like to take advantage of all the tooling that's there already for Android and iOS, and we want to use it very much. So what are the issues? First, as you can see here, we can run it on Firebase Test Lab, but you will see no test duration. Second, there's no isolation between tests. And third, you would have to create redundant builds, meaning redundant costs and money loss. So what does it mean, slow and unnecessary builds? So when you run integration test, you have to pass the target file. Usually you have at least one test per file, sometimes multiple tests per file, but you don't have all the tests in one file. Usually you have multiple files. So if you have 10 files, you would have to build 10 APKs or on Android. So 10 times you have to build the app, which takes more time. Time is credits, so credits on CI/CD services money. You could think, okay, let's bundle them in one file. And it's a very good idea, especially in a first look, I would say. We call this approach primitive test bundling. So you could create a file like bundletest.dart when you just import all those files and run all the code from this file. So you end up in one build and one APK, which is pretty good. And we solve this first issue of unnecessary builds. So let's see how it works when we actually run these tests. So the primitive test bundling seems to work fine. When you have 4 tests and in the second one, you would have a false assert. So for example, you expect something else that actually is there. You would have 3 successful tests and 1 failed test. But what if you have not only an easy case when it's just expect true, false, but you actually acknowledge some crash in your app. Like you actually end up in a situation when some other library, maybe native library, or I don't know, there are some problems with the backend that are unexpected, and your test crashes. Like you would run exit you would call exit straight from your app code. Because of all the tests are in the same process as the app, and this is one runtime, and all the tests are actually run at the same time in this like integration test design and architecture, this would bring down the whole test suite. So if you would have 100 tests in here and you crash on 98th test, you would end up with 0 results. So you already ran 4 hours of tests and you don't have results from those 4 hours because in the end something just crashed. And as we already said, there are no test durations, so you always see less than 1 second because all the native tests are recreated from Dart tests after all the Dart tests are run. So in integration tests, how it works is that you create 100 tests 100 tests are run in Dart, and then the results are being sent to the native side. So from the native perspective, all the 100 tests are instantly executed. Why it's important? Because you could have a 4 hours of test run, and you would like to know that, for example, one test took an hour, and you didn't know that, and there is only one test that takes 20 or 30% of the time, and you could skip it, for example. And a small thing that's actually, it can be very beneficial in terms of cost effectiveness is sharding. So sharding is a feature where you can actually split. You have 100 tests, and they are split into, for example, 5 same emulators and parallelized, so that it takes like 20 tests of duration, and you have 100 tests already done. So sharding means effectiveness, especially cost effectiveness and time effectiveness. And with the design of the fact that you have to, in integration test, you have to run all the tests and send them. It's just not possible. It's fundamentally broken. So you cannot achieve that with first-party solutions.
All right. So Matti has outlined a lot of problems. And of course, there's a question, how do we solve it? So here, Patrol enters the stage. And what are the core pillars of Patrol? So first of all, we wanted to allow for those native UI interactions. So those location permissions, maybe notifications, and also interactions with the outside of your Flutter app under test. Also, we wanted to build it with Flutter, and we open sourced it, so you can inspect everything. You don't need to trust us with everything. You can see the code yourself. You can contribute if you would like. Also, we wanted to improve the developer experience with better syntax. So whatever was redundant for us, or maybe you want to make some smart default, we did so. So you still have control over everything, but you don't need to specify everything that is not necessary. And of course, it's compatible with device farms because we want to run end-to-end tests as close to the real environment and for the cases that real users will use it.
If you feel like it's a lot to digest and you would like some help from us, from LeanCode team that develops and maintains Patrol, we offer some services. First is Patrol Setup, where we can set up your code base with Patrol and start with some set of UI tests, integrate with your environment, meaning your CI/CD, device farm, your tooling, and so on. And another one is dedicated Patrol training, where we can provide your team with some workshops about how to use Patrol, some advanced Patrol usage, test architecture, and best practices.
All right. So what actually is Patrol? So first of all, it's written in Dart. So it's specifically created for Flutter. So we don't need to support all of other frameworks. There are no compromises related to that. Also, we still use Flutter test for Flutter features of your app. So we basically extend it. But for the native features, we use XUI test for iOS features and UI Automator for Android. And of course, there are those smart defaults. So you don't need to worry about all of the things that we believe that most of the time we can go with defaults. And of course, there's this compatibility with device farms and native tooling. Okay, so basically this is the architecture of Patrol. So going from the bottom, there is the test package, which we found no issue with, and we still use it under the hood. There is Flutter test. So you can still use features from Flutter test, but we extended it with Patrol finders. So you can write more concise syntax, which we'll touch about in a moment. And it will help you write shorter tests, and you will get better performance with that. And of course, on the top barrel, there is a Patrol package, which also allows you to use those native interactions. Okay, so basically, how can you use Patrol? You just need to add it as a dev dependency in your YAM. and you can use Patrol. So you get everything that I've just said, or maybe you will decide to just use Patrol finders without those native interactions. Then you can use it separately without Patrol package.
Right. I think one thing I like to add here, we can go to the next slide, is that a Flutter test is a perfect low-level API. It's awesome. We love Flutter test package as a low-level API to find things and to interact with widgets. But if you write the tests on a daily basis, you would like to have something more high-level, and that's what actually Patrol finders are, which Oscar is just showing on the screen.
Yeah, so let's go through a couple of examples so you get some feel what is actually Patrol finders and what the syntax looks like. So in here, there's a very simple snippet that you can see. So in this case, we're just selecting elements by the text. So sign-in text, and we just tap it. And those smart defaults that we have under the hood will actually make sure that the sign-in text is actually on the screen. It's visible. So we want to try to tap it if it's, for example, hidden under some other element. And we don't need to specify some hard code that wait. So we don't need to say, wait for 1 second and then tap the sign-in button. And the second line is to enter the email text field with our email address. Yeah, so basically we extend the Flutter test, but do not replace it. So you can still use all of the features that it would normally provide. But we want to counter those flakiness. We don't want you to need to specify those pumps, those waits, which some frameworks force you to. And the syntax is better to understand. So basically the test file will be shorter and easier to understand. And of course, since Patrol finders is easy to select elements, then you can use it not only in your end-to-end tests, but also in your widget tests, golden tests, and integration tests. So here you have a comparison how Patrol finders compare to the Flutter test package. So you can select element by the widget type or by the text, and you don't need to really specify, like in here, find by type. You don't need to write that. We just specify widget type, text. In the third line, you can see by key. Next, there is a find by icon. So we just provide this icon that add. And of course, regular expressions are also supported. Okay, so yet another example, maybe more real-life scenario, and because we have a couple of steps. So this syntax should be pretty easy to read for you. So basically, we're just tapping the button by the widget type. Then we long press other button. We provide some text with the text field. Then we wait for the icon. Next, we can select element with index because, again, smart default in other actions, if you do not provide the index, then you'll tap the first item. So the test won't actually fail. If you have two similar buttons, it will just tap the first one. And later you can scroll to element and then tap it. And last line is actually very interesting thing. So since we are attached to the Flutter app, we can still check widget properties. So when you compare Patrol to the black box frameworks, you don't have the access to this stuff. So in here, we can just tap the red container, which is very interesting. And in some cases, it might unblock you from testing some complex scenarios. Again, the syntax is much more concise. So your test files will be shorter and easier to understand, especially if you have multiple QAs, or maybe you want developers to read those tests and maybe contribute. So it's basically beneficial to the whole team.
Yeah, this is actually an example from one of the first slides. So on the left side, you can see the same thing I already showed about, three enter texts and 2 taps. And you can see on the right side how easy to read that is. Like you can see 3 lines with enter text and 2 taps and wait until visible. That's what we talked about the developer experience.
Yeah, basically Patrol aims to describe test steps as close to natural language as it's possible. All right, so yet another case, and this time I want to show you that the syntax actually follows how you think about interacting with elements. So on the left, first you're thinking about action, then you think about what you want to perform this action on. But with Patrol, basically you can see that you want to have a list view with subscribed text, and then you want to tab it. So I believe it feels more natural. In here, there is this hardcore example that Matti has earlier shown. So in here, I believe if I wouldn't be prepared, I wouldn't understand the left snippet because we have ancestor and
Me neither.
Yeah, exactly. And on the right, I think it's as readable as it gets. So we're trying to get the list style with activated text, and then we want to tap the learn more by key. All right. So once again, I want to say that the Patrol finders do not replace the integration test package. We extend it. So all of those features that were earlier, you were blocked by interacting with. So those pop-ups, native pop-ups, those web views, those locations, and outside apps are basically allowed by Patrol. And what I mean by that, we have a dedicated APIs for a lot of those elements. So here you can see the code that does exactly that. So the first snippet is the interaction with permissions dialog. You can also do some other stuff. So for example, you can enable cellular data, disable Wi-Fi, you can interact with dark mode, and a lot of other stuff. So when you encounter some, for example, native pop-up permission, you do not need to specify up this native text, but there are ready-to-use API called Patrol methods that you can use for that. And yeah, here I have some examples to show you how this looks in action. So in here, we'll have notifications. And you can see both Android and iOS. And we don't specify to tap allow text, but we just call grant permission when in use, for example. So I believe that's really easy to maintain because you don't need to worry about what system user is using, what version of the system, because we have different pop-ups for different Android versions. So in here, you don't need to worry about that at all. And yet another example, we have those generic permissions, and there are a lot of those because sometimes app checks if you will allow it to interact with your contacts or your camera or your microphone. So there are a lot of types of permissions, native permissions, and again, you don't need to really worry about that because we have ready endpoints for that. And lastly, you can do basically anything. And what I mean by that is that you can automate really crazy scenarios, which in this example, you can see in the video that you can enter contacts app, you can fill up all of the text fields, you could try to access text messages, read them, then go back to your app and maybe provide the OTP. So sky is the limit. In this case, you can do anything you can think of, but there are, of course, some downsides. So the more native code, test code you will write, the more difficult it will be to maintain, because when you write Patrol stuff for your under test, then it should be easy to maintain because you can interact with keys, with widget keys, with widget types. But in here, for example, if the contacts app would just change their, for example, texts, then you need to update your test. But still, this change was not really made by you. So yeah, you should really think of it as a last resort, but nevertheless, you are allowed to do anything you want. Just try to keep it under control.
Yeah, it's always good to have an escape hatch, even if you would not use it. So even if, for example, we as Patrol team don't develop something that you might need right now, you can just use this raw API to do almost everything.
And Patrol ecosystem grew a lot over the years, and we have a lot of support tools that will help you use Patrol effectively. So first of them, the most basic but very important is Patrol CLI, because we have our own CLI for running tests. And basically it allows you to run the test by specifying what tests you want to run. But there are some additional features, so some compatibility checks. Also, you can run Patrol Doctor just as Flutter, and this will help you debug your local setup for Patrol. Also, this is a very important feature of Patrol. We have Patrol Develop. And what Patrol Develop does is just run the test, but in develop mode. So when you make any changes to the your test code, then you can make those changes and basically hot restart the test, just as Flutter does. So you can, for example, write tests step by step. So we can write just first 2-3 steps, run the develop, and see if they pass. If they pass, you add another line, and again, you can just write new tests incrementally. And other use case, very important for me, is that it also helps you with debugging the tests. So basically, if something happens with your test at the end and you are not sure which line fails, then you can just comment them out and add them one by one. So it's very easy to debug failing tests, which if you have a lot of tests, then maintenance becomes a big issue. So the easier it gets, the more time you will save to write, for example, new tests.
Yeah. Another quality of life feature, another developer experience thing that we mentioned, that we are all about DevX.
Exactly. So, and of course, you save time because you only build the app once with Patrol Develop, and then you hot restart it just as the Flutter developers restart their app. Yet another quality of life feature is Patrol VS Code extension, which helps you, especially in very big test suites. So you have a lot of tests. You can navigate them not only by just browsing the files, but you can see dedicated Patrol section in your text explorer. And it also supports the hot restart feature. And it's just really nice to have those tests visualized, and you don't need to run individual tests by Patrol CLI and providing the full name of the test. So it makes test running easier. Another tool that we have in the Patrol ecosystem is DevTools extension, and this has two big uses. So the first one is that you can inspect your Flutter widget tree, and it's especially useful for QAs because they don't really need to know the app Flutter code base to navigate it, for example, to some specific widget to assign a widget key to it. They can just use DevTools extension, click on the widget, and then they will be redirected to the IDE with this widget already highlighted. So it's very easy to navigate. You don't need to be a Flutter developer by heart. And the other use case is that we also have a separate tab for the native tree, which really helps you out because when you want to write some native interaction, for example, with this contacts app, you can just inspect the tree and you will see that the text field for name of the contact has this resource ID. And then you just write this resource ID in your test and you have already test step. So you don't need to really worry about those external apps. And something that we've developed with Patrol 4.0 is that we also support the Patrol web. And this is really interesting because it was a very big feature for us. We had to rewrite a lot of API, but now...
Again, we had to rewrite Patrol again.
Yeah, exactly. But right now, it made our API very flexible. Because if you remember the syntax from earlier, you have platform, that, and you can type mobile, which will be universal for both Android and iOS. But you can specify just iOS if some step would be just for iOS. And in here, we have platform.web. So whenever a new platform would come up, we have a very flexible API to extend. So in the end, it was worth it, but it was a very interesting journey. Okay, so let's go further. Why do we believe it's worth to trust Patrol? So first, it's open source. So you don't need to trust us with anything. You can inspect the code yourself. You can assess it however you want. You can contribute if you believe something is not optimal. We have extensive docs and we have a lot of things there. So we have some articles that explain some complex use cases. We have guides for native interactions, for maybe how to write tests effectively. So we try to make it very versatile. So whatever knowledge you might require, you should find it there. Also, it's developed and maintained by LeanCode. And what I mean by that is that we use Patrol ourselves, and it started as like an internal project. And only after we saw that how was the potential behind it, then we shared it with others. And basically you can trust us with maintaining Patrol over the years because we use it ourselves for our clients and our projects. So it's very important to us too. And of course, we had a lot of production grade apps already using Patrol. So we very much have it in interest to maintain and keep them happy.
You've seen a lot of known brands in one of the first slides we've shown you, and probably majority of them is using Patrol to assure the app's quality.
And the last argument is that Patrol has been developed since 2022, so we have it's not a novelty tool. We have some experience. We have 4 major releases, so we feel pretty comfortable going forward.
Yeah, and a lot of major bugs fixed already. Okay, we've already covered the technical part, like how would you write tests and in which tool, which is Patrol. Let's assume we already have written our tests. And now let's think about all the opportunities that we have with how to run them, when, where, what to do with our environment, and all the things that we have in our organization. So what we want to talk about right now is the testing tools, setups, and strategies. So first, strategies about when to run end-to-end tests, then where to run them on virtual or physical device farms, how to orchestrate them. Do we want to orchestrate them locally and have more control, or delegate it to the cloud solution and just use a remote service? Finally, when you run the tests, and we already successfully run all the tests, we would like to have a report from that test run. So we would like to cover some test reporting tools. And last but not least, kind of a meta topic, which is test management. So how to manage test scenarios, is there any class of tools for that? How would we, consider it in this whole ecosystem of testing? So because we use Patrol, which is enabling us to use all the tooling that native apps can use, because Patrol tests translate to native tests, it's very interesting for us because now we can use a plethora of solutions that were unavailable for Flutter users, like device farms from native apps, test runners for native apps, orchestrators, reporting tools, management tools, and so on. So now we can finally take advantage of that, and let's see what we can do. So first, test run strategies, when to run your end-to-end tests. First, you can run it as a PR pipeline. PR means pull request. So if you would like to run it on every PR, what should they be? They should be fast and stable, because the worst thing you want to have is to block your development. You don't want to block all the features from being merged because something is broken with your end-to-end tests. And I don't mean broken by tests are failing. I mean broken because they're very slow, or they are flaky, or they are crashing because of some setup, like the device is crashing, or you are out of memory, for example. That's why they should be fast, meaning let's take one or two crucial business scenario that you would think I I don't want to have code on my main branch that fails in this. This could be your scenario. And then it should be stable. So for example, consider running it only on virtual devices like emulators so that you can have you can recreate exact the same environment all the time. Instead of, thinking about some physical device that might be broken tomorrow in your office closet or something like that. One of that scenarios could be the simple smoke test. So does the app even start? So if it doesn't crash, then it's okay. This is a good example. Another strategy is on demand. This is just a button you can press. It's always good to have such an option. Another strategy is to run on deployment tests. So when you deploy to the next environment, for example, from test to staging or from staging to production, you would like to have some test runs. So for example, they should prove something. For example, you want to be sure that when you migrate to another environment, you are able to transfer money from one account to another, or that you are able to see an account balance, something like that. So something that's very crucial, and you know that after this migration, this works. Last but not least, nightly builds. This is one of the, I think, the most popular option, and it's very nice, and we recommend it to everyone. This is when you run tests every night at 2 a.m., for example, when nobody's working and you don't block anyone, and you can just run some infrastructure and you can run tests for 4 hours. Why would you want to do that? Because they can be flaky, the tests can be flaky, and it's okay for you. They can take more time. It's okay for you because you are not blocking anyone. So you can run them for a couple of hours, and you can have actually results from all the tests that you have in your code base. So it's good to keep track of the statistics. You can see every day you start working with a nice notification about how was the test run this night. Okay, we know when to run. Now let's think about where to run them. So we run tests on either virtual devices, meaning Android emulator or iOS simulator, or physical devices, meaning real physical Android or iOS device. First, virtual ones. Virtual devices, you can either use your own on the computer, or you can use some clouds. They are relatively cheap. Usually they're cheaper than physical farms. So what are device farms? Because I didn't explain that. These are services that offer you access to like running your tests on some devices remotely, like local, like virtual devices or physical devices. So virtual devices you can build faster for iOS. You can also run faster on them. They should be more stable because you recreate the same environment. You are more like sure that it's the same emulator. They make better use of sharding because they can easily replicate. They don't have to have another real device. They can just create more emulators. And there are a couple examples. One is Marathon Cloud for both Android and iOS. They have this promise of running all the tests in 15 minutes because of sharding. And we as Patrol, we support Marathon Cloud as well. We also use emulator WTF, which is Android only emulator cloud, and we use it also in Patrol. We test Patrol with Patrol, of course. And also you can use Firebase Test Lab, which is very, very popular, and they have both physical and virtual devices. About physical device farms, again, Firebase Test Lab, very popular choice, especially easy setup because you might already have Firebase or Google Cloud. They're both virtual and physical. They have automatic JUnit output, which is very nice. You will see why in the next part about reporting. And they could be very cost effective because they have some free tier. So if you're doing one nightly build, for example, maybe it's for free. So you might want to use that because you might have, already you might integrate end-to-end nightly build testing for free, which is very nice. Another very popular farm is Browser Stack. We also work with that in some project. And another popular one is Sauce Labs, which is also a native physical device farm, and we also work with it in some projects. Okay, now let's think about execution. So the orchestration, because we have two options. First is that we control the exact execution. So, for example, we are connected to some devices or emulators, and we have our, GitHub action or Jenkins pipeline, our CI/CD pipeline, and there we control. Let's now use patrol and test on this, and this device, and then let's wait for the results and, for example, send them to some other service. We might use some test runner. There's an open source test runner called Marathon. We support working with this test runner. It might be helpful because you can run locally, and you can, even with your office closet, like I mentioned, with your local physical devices, and you can have automatic retries, sharding, reporting, flakiness detection, and so on. And so it gives you a lot of control, but also more maintenance costs because, they're your devices in your closet, and you have to sometimes go there and literally physically restart them or something like that. On the other side of the spectrum, you might do remote execution, meaning you use Firebase Test Lab or Browser Stack or any other farm, and you just delegate execution of those tests. You just build the test package, you send it to them, and you just tell them to run it. And you don't know when the tests actually finish. You can't constantly see and control everything. So you have to do more scripting around to track the status, to do some, polling and actively sending requests every couple of seconds to see if it's already done or not, if it's failed or not. And then you have to download the artifacts, move them to some artifact storage that you have, and so on. But on the other hand, you don't have to care about some device being disconnected in the mentioned office closet. Let's assume we already ran it. All the tests are run, and now we would like to see some results. So how the test reporting works. Patrol uses native tooling. Like we already mentioned, it uses UI Automator, Android tooling under the hood, and XUI test tooling under the hood. And both these worlds, they generate reports after the test run. Android generates JUnit XML, iOS generates XC result format, and XC result format can be also automatically converted to the JUnit format. Why would we do that? Because JUnit XML format is the golden industry standard for test reports. Not only end-to-end test reports, but all the test reports. And it means that all your CI/CD services, device farms, possibly every tooling in the world, if they support any test reports format, it's going to be probably JUnit XML. That's why it's very convenient to have that. One of the most popular reporting tools is Alur Report, and it's something that's open source. It's part of proprietary Alur Testops, which is test management, much broader topic tool. And Alur Report is already in some products. For example, Marathon Cloud or some other device farms, they might already introduce Alur Report as part of their stack. It tracks retries, logs, keeps history of your tests, statistics, flakiness, all of that. So if you want to have your local farm or local orchestration or local reporting, Alur Report is probably your best friend. And usually device farms have some form of test reporting, either Alur or their own or some other tool. But usually device farms are these huge tools that have everything inside. This is how it looks like, the Alur Report. As you can see on the left side, you have some test suite. On the right side, some test details, some graphs and timelines. Okay, last but not least, you have test management tools. And this is something much, much, much more broad. than all the tools we mentioned, because this is kind of a meta tool, and it's not related to automated tests. It's just related to testing in general. So one of the definitions I found on the internet is test management tools are used to store information on how testing is to be done, plan testing activities, and report the status of quality assurance activities. So usually it has integration with Jira or some other ticketing system. You have an interface for managing manual test cases and automated test cases. They can connect to a lot of tools like Azure DevOps, Browser Stack, device farms, a lot of stuff like that. And some examples are X-Ray, TestRail, and already mentioned other test ops. They are not related to test execution directly. Usually they have some intermediate interface that allow you to have a hook to run something, but the actual execution is done in your CI/CD or some other place. They're more of a meta tool that combines everything in one place. This is how it looks like. And let's go through the example setup for one of our clients that are actually have right now. So when to run tests. The client picked nightly builds on test environment at 10 p.m. So every night, all the tests are run. And additionally, they have an optional manual trigger on PR. So if you think this PR is very important in terms of running end-to-end tests, you can queue additional check. Where to run tests? We decided on browser stack and physical devices. We also experimented a bit with virtual devices, but this project is very much related to real device integration. And then we report, we gather all the test artifacts from browser stack, which include reports from tests in the JUnit format and XC result format, all the instrumentation logs, device logs, and the video from run. And as test management, the client uses Azure DevOps because everything's in Azure DevOps for them. And we have also a Teams card notification with summary of all these steps. So the test run strategy is, this is just a schedule in Azure YAML. Then we have an Azure pipeline. You can see multiple stages. And on the left side, you can see the manual trigger. Patrol test succeeded. You can requeue. You can queue the tests. It's the optional check for them. Then it's going to be run on browser stack with the video and all the logs. Then we get all the artifacts from build. You can see this is from Azure DevOps. It's already uploaded to Azure DevOps. And then you have this beautiful report in Azure DevOps. So you can see all the tests passed. Run duration is actually 8 seconds longer than before. And so on. You can compare to other test runs. And in the end, on your MS Teams channel, you have a smooth summary within the card when you can see some chart and you can see how your last night test run went.
All right. So before we wrap up, we wanted to share some insights with you based on our experience with different projects and different clients. So let's start with the most common mistakes that people do when writing end-to-end tests. So the first problem is that when people start writing end-to-end tests, they get this new tool, new toy. They start overusing it. So they start treating them basically as unit tests, and they write tons and tons of those tests, which basically it's a good intuition for testing, but not the best idea for end-to-end testing because those tests are slow and expensive to run. And they are difficult to maintain because, a lot of stuff can go wrong during those tests. As it was already said, we are testing the system, not only the app. So something in the backend can go wrong. Some API could change. So if we have tons of those tests, the investigation of the root cause it gets pretty difficult. Also, those tests are flaky. Again, we're having the whole system. So everything can go wrong and there are a lot of variables. And of course, people sometimes tend to overuse smoking, and this in the long run makes those tests not truly end-to-end, because if you mock stuff, then you are not as close to the user as maybe you should be. Also, some people, this is also a good practice in other types of tests, is that to left shift the test. So you want to start testing as soon as possible. But for end-to-end testing, this might get problematic, because if you write the test too early and, for example, over a short time, the feature requirements will change, then you also need to update your tests, which again, it's not that easy. And also, something that also relates to big number of end-to-end tests is that people tend to also try to test corner cases. So basically, the best thing, or maybe the first thing that you should automate with end-to-end tests, is checking your core features of your app. So you don't really want to check if your login flow, when you provide incorrect credentials, will throw correct error message. But you want to make sure that, for example, your e-commerce app will actually be able to complete a transaction. Or, for example, you are able to book your barber fully. So you can complete the main flow of your app. And then you can, of course, multiply but by some other configurations, etc. So what we recommend how people with writing tests is that the best way to identify elements in your Flutter app is by using widget keys, because you can write them specifically for testing. So you don't, for example, need to rely on text, because text and copy changes over time. Maybe the UX decides that we want to change our approach, how we communicate with clients. So it would break the test and we would have to update a lot of stuff. But with the widget keys, which are assigned specifically for testing, the maintenance is easier over time. Also, we recommend storing your keys in one place, and then you can use the same keys in your tests and in your Flutter app. So they are shared between those two places. And this really helps you just seeing what you already have in place. So for example, if you have some screen and you have a lot of keys there already, then it's easier to, for example, add a new key, or maybe you will see that the key is already assigned to the feature, the widget that you want to interact with your new test. One more thing, we strongly encourage you to having a very specified and deterministic test paths. So a big problem with some tests is that if you add too much conditionals, so just adding some ifs to your test flow might not be a good idea, because when something fails, you will need to investigate what went wrong. So what was the actual test? If you start rendering out, it becomes difficult. And yeah, tests should be deterministic. So if the test fails and you get the fail loss, it should be pretty clear what went wrong, and you don't need to investigate as much. And it also eliminates a lot of fakiness, because if the test is deterministic and it's written correctly, then it will fail only if we have bug in the system and something actually broke, or maybe the business changed and we just need to update the test, and you will be sure. So basically it should be only one of those two things that you need to do. And of course, this is like the core idea behind tests. The test, especially end-to-end tests, should have one clear goal, which is to make a purchase, to book your barber, or to sign up to the new application. So you don't want to retest those small features, or maybe you shouldn't start with them, but the most important parts of your system and the critical paths. And it's always a good rule to write a very verbose test description. So you don't need to read the test steps. You can just take a look at the test description, and it will really help out deciding that, okay, we have sign up flow automated, and we have this test in place. So maybe even developers could just open the test file and see, okay, this is already ready and in place.
Right. Yeah. So to sum it up, again, thank you all, and thank you, Oscar, for it. It was quite a ride to have to talk through all these things with you during this webinar. But again, if it was too much for you to digest, or maybe you already want to write some patrol tests, and in your specific project you don't want to think about setting it up from scratch, call us, right? And we can help you with that. We can help you with the setup. If you want to learn more and you want your team to learn more, ask specific questions, have a helping hand from LeanCode, we offer also patrol trainings. Thank you very much again. Thanks for watching, and happy testing with patrol.